We've got a binomial probability problem here, and we're looking at some information about an audit at a hospital. They found initially 15% of patient bills contained errors, so they did a improvement project. Now they think 5% of patient bills will have errors, and so they've tested this with a sample of 10 and they found 3 errors. Okay, so in this first part of the problem we say name the following variables. So n is 10, our sample, probability is 0.05, and we found 3 defects. So on the face of this you might say, well, we found 3 out of 10, or 30% of our sample here had errors. We think the error rate is 5%, so you might already think there might be a bit of a problem here. But let's test this here with the binomial probability. And so that's the next part of our question here. What is the probability that the team would find this many or more errors if the defect rate is actually 5%? Okay, so 3 or more. Okay, and you remember in a discrete probability, we could have 1 or 2 or 3 or 4, unlike a continuous, right, which could have 3.5 or 3.9. So it's a discrete individual countable item. So 3 or more, and that's also going to be, the probability is going to be, the way we would calculate that, I should say, with the binomial table is 1 minus the probability of less than or equal to 2. Okay? And so remember, just be careful and read carefully what it is you're looking for. Is it less than 3? Is it less than 4, or what have you? So in this case we're looking for 3 or more. Okay, and so we would draw the cut line on that would be right along here, right? So 3 or more would be anything above that, and then that would be 1 minus, in these continuous tables, everything less than that. Okay, so our table that we're looking at here is n equals 10 and the probability is 5. And the probability of 2 or less in this cumulative table is 0.9885. So we have 1 minus 0.9885, which is going to be 0.0115. Okay, so our probability then, to put this back to our problem, I'm getting that from right here, right? So we said 2 or less in the cumulative table, 0.9885. Putting that back into our problem, then we're saying if our defect rate is actually 5%, there's just over a 1% chance of finding this many errors in a sample of 10. Okay, so almost 99% of the time, if your error rate was really 5%, you would almost never get this result, right? 1 in 100 times or thereabouts. So based on the answer to that, what would we say? Is this working as stated or not? Well, it seems very unlikely. So I would say is not working as expected, because we found 30% of our sample had errors. Now there's many things that we could do here. If this were a real life example, we might say, well, we want to sample more than 10 and really find out if that's the case or not. But in any case, based on these results, this sample, we would say, and that result, we would say, no, your error rate is not 5%. Very unlikely. All right, so now let's move on to the second part, and I've got that. All right, so we've answered then A, B, and C. Okay, so we don't have to concern ourselves with those anymore. Now we've got a new set of questions here. We've now sampled 25, n is 25, and we found 5 errors. And we think based probably on those earlier results that our expected error rate is 10%. Okay, so just putting that in the same terms as part A for the second part of the problem here. N is 25, X is 5, and P is 0.10. All right, so now we've got a new probability table, right? Then a new binomial table down here where N is 25, and we've got a probability of 0.10. So this is the column we'll be interested in. Now let's look here. They say if the improvement team, okay, if the improvement team now samples 25 bills, found 5 errors, rate of 10%, what is the probability that the team would find 5 or more? More than 5, excuse me. More than 5. Probability is more than 5. Errors, if the error rate is actually 10%. Okay. So more than 5 would be, 6 or more. So our cut line is going to be there. Okay, and in our cumulative table here, then we would say the probability is going to be 1 minus 0.9666 here. So I'm taking that value right there. That's the one we're looking for. And so that's going to be then 0.0334. So not a major difference, but 3 times more likely compared to that first result, right? So we have 3% chance of finding this many compared to the just over 1% chance in the earlier part. So the answer to part D is 0.0334, okay, based on our 1 minus the 0.9666 calculation there, to say the likelihood of finding this many or more errors if our error rate is actually 10%. Okay. Now, based on the answers above, the team's assumed error rate of 10% is less likely or more likely to be correct than the assumed 5% rate in the earlier part. So in this case, this is more likely correct, 10%, but even so, it's still not very likely to happen that we would find this many errors in that sample size. But it's a better, 10% is closer than 5% to our error rate if these are the rates that we're finding. Okay, so to explain this in one sentence, we'd say the hospital's billing error rate is closer to 10% than 5% based on the results of the samples taken by the team. So that's all we would have to say there. And that's based on the probability. Actually, we could probably add that to that sentence too. So based on the probability of each result, the 10% error rate is probably closer than the 5% based on the samples.